I'm Sonakshi, your mathematics teacher for today. Today we will discuss your chapter number 15, which is probability. All of you have done probability in 9th class also. Now in 10th we will discuss about theoretical probability. In this we will discuss about elementary events, some of the you can say sure event, we can do about impossible event and complement of an event, and we will do questions based on all these types. All of you have done in 9th class about experimental or empirical probabilities of events, which were based on the results of actual experiments. Like we have discussed an experiment of tossing a coin 1000 times, in which frequencies of the outcomes were as follows: head 455 times and tails 545 times. So based on this, the empirical probability of head was 455 by 1000 and empirical probability of tail was 545 by 1000. Now, suppose we ask what will be the experimental probability of a head if experiment is carried up to 1 million times, or suppose 10 million times, and so on. So you all will feel that as the number of tosses increases, the experimental probability of a head or tail seems to be setting down around to the number 0.5 or 1 by 2, which is what we call the theoretical probability of getting a head or tail. So in this chapter, we will do about theoretical probability. Let's take an example. Suppose a coin is tossed at random. So when we speak of a coin, we assume it to be a fair coin. Fair coin means it is symmetrical to that there is no reason for it to come down more often on one side than the other. Okay, and by the phrase random toss means the coin is allowed to fall free without any bias or interference. Now, so what I said, we toss a coin at random. So we know that in advance that the coin can only land in one of the two possible ways, either head up or tail up. So we can reasonably assume that each outcome, head or tail, is as likely to occur as the other. Or we can say that the outcome head and tail are equally likely outcomes. Let us take one more example for equally likely outcomes. Suppose we throw a die once, and for us a die will always mean a fair die where only 6 outcomes will be there. We all know that number 1, 2, 3, 4, 5 and 6 are there on a die, and each number has the same possibility of showing up. So equally likely outcomes of throwing a die are 1, 2, 3, 4, 5 and 6. Now, but the question arises, are the outcomes of every experiment equally likely? Now, let us take one more example for that. Suppose that a bag contains 4 red balls and 1 blue ball, and you draw a ball without looking into the bag. Now, what are the outcomes? Are the outcomes a red ball and a blue ball equally likely? Now, we all know that since there are 4 red balls and only 1 blue ball, you would agree that you are more likely to get red balls than a blue ball. So the outcomes are not equally likely. So however, the outcome of drawing a ball of any color from the bag is equally likely. So all experiments do not necessarily have equally likely outcomes. So in this chapter, from now onwards, we will assume that all the experiments will have equally likely outcomes. Now, in ninth class, we all have done experimental or empirical probability. What was it? It was number of trials in which the event happened upon total number of trials. Now, in 10th class, it is theoretical probability or probability of an event, which is number of favorable outcomes upon total number of outcomes. Let's take an example. Now, for example, a coin is tossed. Find the probability of getting heads. Now, I said a coin is tossed. First of all, you have to write down how many total outcomes will be there if coin is tossed. All of you know that if a coin is tossed once, either head will be there or tails will be there. So that means how many total outcomes? 1 and 2. So total outcomes will be 2. I said find the probability of getting heads. So how many times heads? Head is only once. So that means what is the probability of getting head? Favorable outcomes means how many times head is there in that. So head is once upon total outcomes, and total outcomes is 2. So probability of head is 1 by 2. Similarly, if I'll ask in this particular question only, what is the probability of getting tails? So what is probability of getting tails? Again, you can see that tail is also once and total outcomes is 2. So probability of tails is also 1 by 2. In 9th class, we have done that. Sum of all the probabilities of elementary events is equal to 1. You can check that now. Probability of head plus probability of tail. 1 by 2 plus 1 by 2. 1 by 2 plus 1 by 2 is equal to 1. So we have checked that sum of all the outcomes is probabilities of all the outcomes is equal to 1. Let's take one more example for that. Suppose we are taking a bag. In that bag, we have one red ball, one blue ball, one green ball, and one yellow ball. So we have taken that one ball of each color in that particular bag. Now, so they have asked find and probability of getting each and every ball is, we can say that it is equally likely outcome. Now, so find the probability of getting a green ball. Now, first of all, total outcomes. How many total balls are there in the bags? So total outcomes, 1 red, 1 blue, 1 green and 1 yellow. So total outcomes is 4 because total 4 balls are there. I have asked probability of getting a green ball. So probability of green ball is favorable upon total. Favorable means how many green balls can be there. It is only one green ball, so and total is 4. So what is the probability of a green ball? Probability of a green ball is 1 by 4. Similarly, if I'll ask what is the probability of a blue ball? So same way, how many blue balls are there? 1. So probability of blue ball is 1 by, again total outcomes is 4. So 1 by 4. In this way, we can find out probability of any ball from this particular bag. I hope this is clear to everyone. Now let's take one more example. Suppose we throw a die once. What is the probability of getting a number greater than 4? Now, I said a die is thrown once. So how many total outcomes will be there if we throw a die once? How many total outcomes? In a die, we all know that 6 numbers are there. 1, 2, 3, 4, 5 and 6. So total outcomes we have 6. Now I said what is the probability of getting a number greater than 4? So let E is the event which is number greater than 4. How many numbers are greater than 4 in this? Number 5 and number 6. Only 2 numbers are there which are greater than 4. So what is the probability? Probability of this event E is, what I said, favorable outcomes. Means how many numbers are greater than 4? We have 2 numbers upon total outcomes. Total outcomes is 6. So probability of number greater than 4 is 2 by 6. You can simplify it also. It will be 1 by 3. And if I'll ask one more from this only, what is the probability of getting a number less than or equal to 4? Now let it be taken as event F. I said number less than or equal to 4. So how many numbers are there which are less than or equal to 4? 1, 2, 3 and 4, because equal to 4 is also there. So how many numbers are there? 4 numbers. So what is the probability of this event F? It is favorable is 4 and total is 6. 4 by 6, or we can simplify this, then it will be 2 by 3. Now a question arises, is this event E and event F are elementary events or not? I think in the starting I have told you elementary events. What is it? Elementary event means which have only one outcome. Now you can check that in this event E, how many outcomes are there? 2 outcomes. And in this event F, how many outcomes are there? 4 outcomes. So that means event E and event F are not elementary events. So we have seen that, also we have seen that sum of all the events, I have told you that probability of E plus probability of F. You can check now. 1 by 3 plus 2 by 3. Again you have got as 1. So sum of all the events is 1. But E and F are not elementary events. Also we have done in 9th class that value of probability always lies from 0 to 1. Now why is it 0 to 1? The question arises. 0 to 1 only, not less than 0, not greater than 1. It is not less than 0. Why not less than 0? Because either it will happen or it will not happen. If it will not happen, that means the probability is 0, so it can't be less than 0. Or if it will happen means it will be a sure event. Definitely it will happen, then that probability will be 1. So sure event, the probability is 1, and impossible event means which is not possible to happen, that case probability will be 0. So that means probabilities of all the events will be from 0 to 1. Let's take any example of impossible event. I have explained you about impossible event means which will not happen. So let's take an example, suppose example for this die only. If I'll throw a die once, what is the probability of getting a number 8? Anyone? Number 8. We all know that in a die only 6 numbers are there, no number 8 is there. So probability of number 8 will be 0. So that particular case is known as impossible event because it can't happen. Then let's take one example for sure event. For this only, we are throwing a die once. What is the probability of getting number less than equal to 6? Less than equal to 6. All the numbers in a die are either less than 6 or you can check that it is equal to 6. So all 6 outcomes will be there. So probability of less than equal to 6 is 6 by 6, which is 1. So probability of an impossible event is always equal to 0, and probability of any sure event which will definitely happen is always equal to 1. Now one more thing we have done, impossible event, we have done sure event. Now complement of a event. What is complement of a event? Like we have taken probability of a number greater than 4, and second event we have taken number less than equal to 4. So number greater than 4 and number less than equal to 4. Greater than 4 we can write down it as not 4, not getting 4. So not getting 4, and here we are getting less than equal to 4. So probability of getting 4 and probability of not getting 4. So what is the probability of getting 4 in a die? Getting number 4 in a die is 1 by 6. And what is the probability of not getting 4 in a die? If we are not getting number 4, then remaining 5 numbers. So that means it is 5 by 6. So that means probability of an event plus probability of not an event is always equal to 1. Not an event is also known as complement of an event. We can give the notation as E bar like this. So event plus not an event, you can check 1 by 6 plus 5 by 6, which is 6 by 6, which is 1. So probability of an event plus probability of not an event is equal to 1. So we can notate not an event as E bar. So if an event is given and we need to find out for not an event, we can subtract it from 1. For example, probability of getting a head from, if a die is thrown, if a coin is tossed once, what is the probability of not getting head? We all know that probability of getting head is 1 by 2. So not getting head will be 1 minus 1 by 2, which is also 1 by 2. Or not getting head means getting tail only, which is also 1 by 2. So any example you can take for that. Let's take one example for complement of an event only. Suppose Reshma and Sangeeta are playing a tennis match. The probability of winning Sangeeta is 0.62. What is the probability of Reshma winning the match? Now what is given? Probability of Sangeeta winning the match is already given to us. What is that? That is 0.62. And they said what is the probability of Reshma winning the match? That means Reshma winning the match means Sangeeta is not winning. So what I have told you, probability of an event plus probability of not an event is always equal to 1. Probability of an event means probability of winning Sangeeta, which is given 0.62. Probability of not an event means not winning Sangeeta or winning Reshma. So probability of winning Reshma is 1. So what is probability of winning Reshma? That is 1 minus 0.62. And what is 1 minus 0.62? How much is it? It is 0.38. So probability of winning Reshma is 0.38. Now let's take example of cards. But before taking that example, let me explain you about cards. How many types of cards are there? We all know that there are total 52 playing cards. Total cards are 52 and there are 4 types of cards, that is spades, clubs, heart and diamond. Spades and clubs, that are black cards, and heart and diamond, they are red cards. And there are 13 cards of each type, means number 1 to 13. 1, 2, 3 up to 11, 12, 13. Number 1 of each card is known as ace. Number 2, number 3 till 10 are the numbers only, but number 11 of each card is known as jack. Number 12 is known as queen and number 13 is known as king. So we have number 1 ace, number 11 jack, number 12 queen and number 13 king. That means how many ace cards are there? How many ace cards? I said every type has 13 cards. So 1, 2, 3, 4. So that means 4 ace, 4 jack, 4 queen and 4 king. Then how many aces are red and how many are black? You can check. Spades and clubs black. So that means out of 4 ace, 2 black Similarly, in every, 2 black and 2 red everywhere. 2 black and 2 red out of these 4s, 2 black and 2 red. So we have 13 of each kind, 4 ace, 4 jack, 4 queen and 4 king. Also they can ask you about face cards. Face cards means where faces are there on the cards, and faces are there only on jack, queen and king. So how many jacks we have? 4. How many queens? 4. And how many king? 4. So that means 4, 4, 4, 12 cards. So total face cards are 12, and out of 12 we have 6 black and 6 red face cards. So based on all these, you can get a question like this. Now, for example, we can get one card is drawn randomly from a deck of 52 playing cards. What is the probability of getting a king? So now they have asked probability of getting a king. First of all, favorable outcomes means how many kings are there. We have seen how many kings? Total 4 kings are there. And total outcomes means how many total cards are there, and total we know that 52 cards. So probability of getting a king is 4 by 52. That means 1 by 13. They can ask you, what is the probability of getting a black face card? Now, black face card. Now, how many face cards are there? We have written there how many face cards we have. Total 12 face cards, and out of 12, how many are black and how many are red? 6 black and 6 red. So I have asked probability of getting black face card. So 6 face cards black upon total is 52. So it is 6 by 52. So similarly, from this they can ask anything. One more example. They can ask you, what is the probability of getting red and king? Now, what is the meaning of red and king? Red and king means that particular card can be red also, and that particular card can be king also. Same card, red and king. That means red kings are required. So how many red kings are there? We have 2 red kings. So probability of getting red and king is 2 by 52. So I think the information about cards is clear to everyone. So you can get any type of question on cards also. So with this information, you can solve any type of question based on cards. Now, we have done a question based on a coin is tossed. Now suppose 2 coins are tossed. Now, 2 coins are tossed simultaneously. So whenever we are tossing 2 coins simultaneously, what are the total outcomes, or what is the sample space? Sample space means what are the total types we are getting. So when we are tossing 2 coins, either we will be getting both heads, either we will be getting both tails, head on first point, tail on the second, or tail on the first, head on the second. So these are the total outcomes. No other possibility will be there. So total outcomes is equal to 4. Now they can ask you, what is the probability of getting 2 heads? So what is the probability of getting 2 heads in this? You can check. 2 heads are wholly there. So that means favorable outcomes 1 and total outcomes 4. So probability of getting 2 heads is 1 by 4. They can ask you at least 1 head. What is the meaning of at least 1 head? At least means that particular number and more than that. So 1 head to we have to take, but more than 1 also. That means 1 head, and more than 1 means 2 heads also we can take. So probability of at least 1 head is how much? Favorable 3 and total 4. So that means 3 by 4. So in place of at least, they can ask at most. So what is the probability of at most 1 head? At most means that particular number and less than that number. So 1 head we have to take, and less than 1 means 0 also, where no head is there. So that means it will be 1 head, and 0 head means no head. So how many again total? Favorable outcomes 3 and total outcomes 4. So similarly, they can ask you about, it was about 2 we have taken coins at a time. So now they can ask you about 3 coins are tossed simultaneously. So I'll write down only the sample space for that so that it will be easier to give you the answer. So whenever we are tossing 3 coins, either it will be all the 3 heads, all the 3 tails. Now, all the 3 heads, then we can get 2 heads and 1 tail, head, tail, head, tail, head, head. Means we have replaced from 1 here tail, from last, then from middle, and then from first. Similarly, tail, tail, head, tail, head, tail, and head, tail, tail. So how many total outcomes? Total outcomes we have got 8. So simple way to write down, if they can ask you how many total outcomes will be there, that will be 2 raised to the power n, means how many times it is tossed. Like we have got 1. If 1 coin is tossed, the base number is 2. And how many times it is tossed, that will be in power. If it is tossed 2 times, 2 raised to the power 2, that means 4 outcomes will be there. If it is tossed 3 times, 2 raised to the power 3, that means 8 total outcomes will be there. If 4 coins are tossed, 2 raised to the power 4, that means 16 outcomes will be there. So same thing is applicable for 1 die, 2 die. If 1 die is tossed, that means how many total outcomes will be there? 6. So 6 will be your base number. And if they will ask you 2 die are tossed, if 2 die are tossed simultaneously, that means it will be 6 raised to the power 2. 6 raised to the power 2 means total 36 outcomes will be there. So we can write down total 36 outcomes. Which are the total 36 outcomes for 2 die? So total outcomes I said 36. So it can be, we are fixing number 1 of the first die, 1 1, 1 2, 1 3, 1 4, 1 5 and 1 6. Now we can fix number 2, 2 1, 2 2, 2 3, 2 4, 2 5, 2 6. Similarly, now we will fix number 3, 3 1, 3 2, 3 3, 3 4, 3 5, 3 6, 4 1 up to 4 6, 5 1 up to 5 6 and 6 1 up to 6 6. So total outcomes you can check. We have got total 36 outcomes when 2 die are tossed. So let's do one question based on this, and then we'll finish up. They can ask you, what is the probability of getting a doublet? Doublet means double number or same number. Means 1 1, 2 2, 3 3, 4 4, 5 5 and 6 6. So how many doublets are there? You can check. 6. So probability of getting a doublet is 6 by 36 or 1 by 6. I hope this is clear to everyone. I hope today's topic is clear to everyone. Today we have done questions based on 1 die, questions based on 2 die, questions based on 1 coin, 2 coins and 3 coins also. You can get any type of questions in your board exams. Please do it very carefully from your exercise. Practice it very carefully. This is very easy and very important chapter. So do it from your NCERT. Thank you very much.